All right, we are going to review 2.3. And we're going to start off with number 7. All right, number 7, negative 2/3 is less than negative 4x. I know why this one's tough. All right, what do you do? What's your first step, Bree? Okay. Oh, okay. So that could work. Then I'm going to show you 2 different ways. That would actually get rid of your fraction, which makes it easier. Multiply by 3, multiply by 3. So what we're actually going to end up doing is going kind of back and forth. So we have negative 2 is less than negative 12x. And then what do you do? Perfect. I like how you came up with that because I would not have done it in that order. Divide both sides by negative 12, and I now have 1/6, right? 2 divided by 12 is 1/6, is less than x. So x is greater than 1/6, and I have to graph that. So when I'm graphing this, it's not negative 1/6, it's positive 1/6. Positive 1/6 is like right there. It's right close to the 0. So x is greater than 1/6. So there's one way to do it. And another way to do it, if I were to show you another way, which might cut out one step. Negative 2/3 is less than negative 4x. So what you can do is you can multiply this side by negative 1/4. If I multiply it by negative 1/4, these negative 4's cancel out. Now I also have to multiply this side by negative 1/4. And what I get is negative 2/12 is less than x. And as we know, I'm sorry, it's not negative. It's not negative. It's not negative. Because a negative times a negative is a positive. So there we have 1/6 is less than x. Same answer, same graph, same graphing right here. 1/6 is less than x, and 1/6 is less than x. They both look like that on the graph. All right, any other questions? Okay, so I just did number 7. Which one would you like me to do? Awesome. Okay, good one. Yes, fractions are difficult. So these are good ones to review, and these are good ones to try to understand. Now I did these in the example on the video, but we will walk through them so that we can better understand it. So what's your whole goal? What is our goal here? What is the goal of these? Okay, part of it will give us if the equation is true. What we're trying to do is isolate the f to find out what the f is greater than or less than or equal to. So there's two ways to do this, and I will show you. Bree showed us how to get rid of the fraction first. So I will show you that. If we just want to get rid of the fraction connected to the f, actually, no. I'm going to show you what I think is the easier way. If we multiply by the reciprocal, do you see how this is the reciprocal? It's the opposite. Reciprocal just means flipped over. So if I multiply it by the reciprocal, what that ends up doing is that ends up canceling all these out, and I'm left with an f on this side. Now remember, whatever I do on one side, I have to do on the other side. So I have 7/3 times a negative 6/7. So I could, if when I'm looking at it, I see that there's a 7 on the top and a 7 on the bottom. So I could cancel those out. So if you know fractions that well and you're like, hey, I have a 7 on the top and I have a 7 on the bottom, let's go ahead and cancel those out. What I'm left with is negative 6/3 is less than or equal to f. Now, if you're not, if fractions freak you out so much that you're not that keen on it, you could go ahead and multiply straight across. Multiply straight across because we'll get the same answer. You get 7 times 6 is 42. 3 times 7 is 21, and it's a negative. Now, 42 and 7 are both divisible by 42 and 21 are both divisible by 7. So if I divide it by 7/7, which doesn't change the value of the fraction, I end up with 6/3. So negative 6/3 is less than or equal to f. Now 6 divided by 3 is 2. 6 divided by 3 is 2, so I have negative 2 is less than or equal to f. So that's how I deal with the fractions. Now, I want you guys to pay attention to how this is written, how this is drawn on the graph. Negative 2 is less than or equal to f. The alligator is eating the f. That means f is larger. So if I go to negative 2 and I fill it in because it's equal to, f is larger. So be careful not to look at this and say, oh, look, it's pointing this way. That's not how it works. That's not how it works. You have to read this or look at it. F is the larger. F is larger. So it goes to the right. If you wanted to rewrite every single problem and put your variable on the left side, then that might help if you did it every single time the same way, because negative 2 is less than or equal to f is the same as f is greater than or equal to negative 2. Whichever one of these is easier to understand and easier to graph, you can write whichever one of those works. If the alligator is eating the letter, it goes to the right. Correct. Oh, I like that. If the alligator is eating the number, it goes to the right. If the alligator is eating the number, it goes to the left. Oh, that's a pretty simple. Nice. Thanks, Canyon. All right, so that was one fraction one. Cody, why don't you give me another one? Let's do another one. Well, another one that you would like to be done on the board. Does everybody have? Yes, I did do all the odd ones, but that doesn't mean they were explained thoroughly. So if they still don't make sense, that's why we go over them. X over -6 is greater than 1/3. All right, X divided by -6 is greater than 1/3. Canyon, what's my first step? Nice. Since it's X divided by -6, I'm going to multiply by -6 on this side, multiply by -6 on this side. Stop. Hammer time. I mean, because I'm multiplying by a -6, what does that mean I have to do? If I multiply by a -6, what does that mean I have to do? I have to switch my inequality. Red flag, I have to switch my inequality because I'm multiplying by a -6. So I now have -6/3. X is less than -6/3. I simplify it. -6 divided by 3 is -2. So I have X is less than -2. Red flag, we multiplied or divide, we multiplied by a negative number on both sides of our equation. So we switched the inequality. We switched the inequality. Make sure you recognize that we switched the inequality when we multiplied by a negative. So we got that red flag. Now, how do I graph that? -2. I go to -2 right there. X is less than -2. So I don't fill it in. And like Ken, just told me, if the alligator is eating the number, then my arrow goes to the left. Yes! Good one. Okay, Cody, any other ones? Or, I mean, there's plenty more fraction ones. Which one would you like me to do next? Okay. Yeah. Anybody else? What number does anybody want me to do? Yes. Okay. So, problem number 9. The word problem. There are at most 36 red and blue marbles in a bag. So at most means whatever I have is less than or equal to 36. Whatever I have is less than or equal to 36. So I have a bag of red marbles plus a bag of blue marbles and that is less than or equal to 36. All right, so I got the first part of my problem drawn out right here in nice colors. The number of red marbles is twice the number of blue marbles. So my blue marbles is B. And I have twice that number of red marbles. So my red marbles is 2B. Because the problem states I have twice the number of blue marbles. My red marbles is twice the number of blue marbles. I don't have twice as many blue marbles. I have a set number of blue marbles, and my red marbles is twice as much as my blue marbles. So there's my equation. 2B plus B is less than or equal to 36. Boom. First step, goodbye my like terms. 3B is less than or equal to 36. Next step, isolate the B. B is less than or equal to 12. So now, we're not quite done. We know what B is, but what's R? So B is less than or equal to 12. What's red? Bree, what is red? Less than or equal to 24. Oh, I keep forgetting to put a box around the answer. Make sure you're putting boxes around your answers.